So our agenda for today is this. We'll start the presentation by talking about HDR and the Cobalt solutions for capturing in HDR, producing in HDR, and then delivering in HDR and SDR. Next topic will be contribution and monitoring over the internet. The idea is to use the internet both as a cost-effective contribution link and use the internet for remote monitoring, and we'll show you some use cases for that. Next topic will be Headend remote management. We'll show you how to build a remotely managed Headend and give you some ideas about that. And finally, we'll talk about some upcoming products from Cobalt Digital, what's coming soon, and what's there and what's coming soon. So let's get into that. Let's start with HDR Solutions. So let's take a look at the HDR production. You obviously start with an HDR source, you capture it, and you're doing some production in HDR. But what about if you have an SDR source? Well, the thing to do is do something called inverse tone mapping, ITM, and that up converts, if you will, the real name is tone map. You tone map, inverse tone map SDR into HDR, and then you can ingest that into your HDR production. So you do everything in HDR. There's a consistent HDR spec into that. Could be PQ, could be S-Log, and you can see that in HDR. Well, what about SDR? There is this process called SL HDR1, which is a technology that we licensed from Technicolor that can create an SDR signal from the HDR signal. So what you get is an SDR signal with metadata, and that metadata allows you to convert back that SDR signal into HDR. So it's something similar to what we did from black and white TV, color TV. You have the base signal, which is SDR, and some metadata that allows you to make it back into HDR. If it's a device that's SDR only, it sees the SDR. If it's something that's HDR compatible, we'll see the HDR, but it's the same physical signal. SMPTE 2108 is the spec or the standard for that metadata in the ancillary space. Then you can take that signal, that SDI signal, you can encode, you can convert that into HEVC 10-bit, and the same thing you have in the ancillary data, you can have in the user data on the HDR. You have a SDR signal with HDR support. And for your legacy, you can take an AVC 8-bit encoder and just support that, and that's going to be just SDR, because it's just not possible to have HDR with 8-bit devices. So that's the general case for HDR production. Now, what do we at Cobalt do about that? That's our next slide. From our HDR source, we have this 9904 card that can do 3D LUT conversion and convert that into various specs. The same 9904 can take an SDR source and then inverse tone map it into HDR. So you have your HDR signal here, you did your production with it, and the 9904, there's an option on it to convert it to SDR. It's the SLHDR1 encoder here. And then after that, we have our 9223 encoder line that will do 8-bit legacy, and our new 9992 encoder that will do 10-bit SDR or HDR. So from an application point of view, this is what Cobalt can do for you on HDR. This is a diagram that shows the whole solution. You can bring your HDR into a switcher, and as I indicated, HDR goes directly. If it's SDR, you can use this ITM process to convert to HDR. In fact, that's a good marketing thing. The technical thing is inverse tone map, but this ITM is also intelligent tone mapping. Or you can do the same thing for archive content. If you need to bring it back to SDR, you can do the SL-HDR1 and have an SDR signal with the metadata. You can send that HDR signal. Encoders and decoders are typically transparent to HDR. You can send that HDR signal to some other location. You can take SDR to HDR here in this other location, and you can transmit that also on the on air, which is SDR plus metadata. SL-HDR1 was written into ATSC 3.0. And this is a 3D LUT. Chris will talk to you about that. Chris?
Yeah, thanks, Hero. And this is, so what we're looking at here in this diagram, it's basically illustrating what we can do with our 9904 UDX card. So what this diagram is illustrating is that with that particular card in a license that we can license up for this card, that gives us the capability to take, for example, an S-Log from a Sony camera and be able to generate and create this cube file that's deriving from being able to work with different LUTs. And what we're showing there is that basically in the past or even now, people are using different devices, external devices within a rack or a workflow to sort of manipulate it and generate these LUTs. But in our case, what we're doing is with the license, now you can do your other processing like color correction, up down cross conversion, working with audio, but also being able to manipulate it and work with the LUTs. And as you can see here in this diagram, we have the live grade and the Wow Wow Wonderlook software that works in conjunction with our card and the license option. So instead of having external devices where you have limited monitoring capability and you may have additional points of failure, we've actually integrated that into the frame now with the card, and we have a way to properly monitor and manage the whole 3D LUT processing. So what Cyril mentioned earlier, being able to not just utilize the Technicolor ITM tone mapping for the HDR, we can also apply the 3D LUT to be able to generate a certain profile by using one of these softwares. So this is what this illustrates, and again, it's a license option that can be applied to the new 9904 UDX card. Next slide.
Okay, thank you, Chris. This is a slide showing the transporting HDR through a network using a compression. So this is to highlight that you bring HDR into the 9904 with the SL-HDR1 encoder code there that generates SDR with SL-HDR1 metadata that's going to be in the ancillary space as per SMPTE 2108. When it goes into the encoder, the encoder is capable of taking that SMPTE 2108 metadata and putting that inside the video elementary streams as SCI messages. Then you have a compressed stream that is got both SDR and HDR. If you apply that on an SDR receiver, it will just play the SDR. If you apply that on HDR receiver, it will play the HDR. That comes into our decoder. The decoder reproduces the SDR with the metadata back in the ancillary space, and that very important it to be frame accurate, and it is. And then if you want to actually convert back to your original HDR signal, you can use the 9904 with the decoder option. So this is an end-to-end compressed transport, and this network can be internet, ASI, fiber, whatever it is. You can transport that end-to-end through some network, long-distance network, preserving the HDR content. And that leads into the next section of this presentation, which is Internet contribution and monitoring. So, compressed audio video can be reliably transmitted in the Internet and received by many types of devices. You know that. You've been doing that. You watch it every day in your home. So, as broadcast professionals, what can we do with that? There's basically two things you can do. You can send contribution grade AV to a professional receiver and use as an Internet as a low latency, cost effective contribution link. We'll show you how to do that. Or you can send a consumer grade version of the content with higher latency for monitoring purposes and pick it up on tablets, computers, smart TVs, and phones. This is the remote monitoring that with today's social distancing, and you can't go to the office. That's what you can do with that. You can be watching your production. And we'll show you that in a diagram. So in order to do that, you're going to need the encoders and decoders with the right feature set. So let's look at what that feature set is for your encoders and decoders. The first one is support for 422, 420, 8-bit, 10-bit. And this is important because the same kit can be repurposed for professional or monitoring. If you're going to hit a low-end consumer device, you want 420 8-bit. If you're doing full-grade contribution, you want 422 10-bit. And there's the case for 420 10-bit, which is what you need for supporting HDR. The next thing you need is full ancillary data support. So at the very least, you need CC and AFD, closed captioning and AFD. If you're doing any sort of ad insertion, you need SCSI 104 support, which is basically conversion from 104 to 35 on the compressed stream. If you're doing HDR, you need SMPTE 2108 support, taking in SMPTE 2108 HDR messages and putting them in the bit stream. And there is the catch-all for ancillary data, SMPTE 2038, which is transport anything. Anything you can dream of ancillary data, you can bring it to the other side with SMPTE 2038. Other thing you would like to be able to do is generate multiple versions of the same input with a built-in downscaler, because you may have this high quality tens of megabits per second professional link or feed, and you may need to generate a lower resolution version of that for monitoring. You'd like your device to be able to support anything from 4K to SD, because basically to repurpose the kit. In terms of protocols, you need to support HLS and RTMP, because that's what you need to send streams to the CDN and to consumer devices. And for the contribution over the internet, you need to support RIST or similar. RIST is a protocol for reliable low latency transmission in the internet. I'll talk about it a little bit more. And finally, you need to support for secure communication, especially if you're going over the internet, because more likely than not, you care about your content and you don't want people to steal it, or you don't want people to be watching it. So you need to be able to somehow secure that content. So that's a feature that you need to be aware of, you need to be looking for. So let's talk about contribution of the internet first. The problem of, can I use the internet as a cost-effective, low-latency contribution link? RIST is a way of doing that. If you've been around for a while, you know that you've been able to buy this from a number of companies, ourselves included. But until a few years ago, those solutions are all proprietary. RIST changes that. RIST is a standardized way of doing this transport over the internet, so you can mix and match. So the way it works is through ARQ. I'm not going to go to the details of this. It's basically, it's not rocket science. If the packet doesn't get there, you ask for it, and a copy will come back. It's a technology that's been around since like the 1960s. Was designed for packet trading in the 60s, and it's simple. It works. So the key things about RIST is that it's now an industry specification. I can't say standard because it's not standard yet, but it will be eventually. Now, what else do we do with RIST? There's this thing called RIST main profile, which adds a number of features to you. The first one is tunneling. So you can use it. Basically, you have to work with IT people, and that makes their life easy. You're gonna have, if you're going through the internet, you're gonna have to open some port in the firewall. The tunneling allows you to do it only one port, and you can open it where it's more convenient. The next thing is encryption. It's the stuff I told you. Your content's valuable. more often than not. It needs to be protected in flight when it goes through the internet. So risk main profile offers the same level of protection as your bank. And in fact, you may have a contract that says you have to do that. So encryption is available, and the next thing is authentication. It's control of who can connect to your equipment. And a typical case of that, you have a reporter in the field. The reporter is going to send a live stream to the station. Is it the reporter or someone trying to hijack the feed and put their content on air? You can't run that risk. So you need to authenticate. So let's talk about the other application, which is remote monitoring. So first way you can do that is directly from HLS from the encoder. The HLS is really the most common consumer grade protocol. It's high latency, but it delivers, right? So one way you can do remote monitoring is to have the playback device, phones, tablets, PCs, whatever, connect directly to the encoder. We support that. It's very simple to set up, but it does not scale to many devices. So the other way you can do this is through a CDN. So the encoder publishes to a CDN, and then the devices, wherever they are, pull from the CDN. For that, you need HLS in a different direction. Instead of having a local server, you need to push the content over to the CDN. And protocols to do that are HLS and RTMP. HLS is the upcoming protocol for that. RTMP is the old thing that's going away, but it's still very much in use because for a long time was the only option. This thing is, you can scale for as big as you want. And with Cobalt, if you want to roll your own server instead of paying for CDN, if say you have some PC there with a web server, we can use that too. And then this way you can also expand the reach of the number of devices you can support. All right, so we have the encoders for that. We have a line of encoders, and this is a feature matrix for video and audio. We have a low-cost 264 encoder, and a little better 264 encoder, and then the 9992 encoder, which is the new one that does all the standards and does both 420, 422, 8-bit, 10-bit. Many of our encoders have also ASI, as well as all the protocols I've talked about, and they differ in the number of channels and maximum resolutions. Those are HD encoders. This is a 4K encoder. For audio, which is also very important, the older ones only do MPEG-1 layer 2 and AACLC, but the new one does pretty much everything you can possibly want in terms of audio. So that's on the encode side. Now on the decode side, we have two decoders, the 9990 and the 9992 decoder. They both are multi-standard decoders. This one will do HEVC and will do 422 10-bit. They all have ASI, and this one goes to 4K. This one is an HD decoder. For audio, complete set of features, and this one has more channels. So whatever you want, we got it covered. I have a more detailed slide on the newer encoders. This 4K encoder has been shipping for over a year. It can do either one 4K or 4 HDs, and the HDs are up to 1080p, right? It's 3G. And the nice thing about this encoder is that it's got full audio support and everything is floating. So you have a certain number of audio channels. You can associate those audio channels with any of the encoder channels. And why do we call it software-defined broadcast encoder? It's because it's a sort of a pay-as-you-go architecture. There's a relatively low cost of entry to get the board, and then you can license the other features as you go. You need more audio, just license it, and it's just a license key. It doesn't need to come back to Cobalt. You need more video, it's just a license key. It doesn't need to come back to Cobalt. And it's got full support for all network protocols. Some of them are under license control, but they're all available. And the story with the decoder is similar. It's got one 4K or 4 HDs, and the same story about audio and protocols. They float, you license as many as you need, and you put them anywhere you want. So this is all available with this decoder, as well as the full set of network protocols. Finally, we have this product called the SafeLink Gateway, which is basically a protocol gateway, and it's used for legacy equipment that you want to connect to the internet but doesn't have the right protocols. You will take the stream from that legacy equipment, convert it to RIST, and then on the other side convert it back. If you're familiar with Cobalt product line, you see that this is our PC card, but it's the PC card with a special software load. RIST support on all those devices. Not all features are available in all devices. In particular, the 9980, the low cost encoder, doesn't do RIST because it's a consumer grade. The 92223 won't do encryption, but everything else is available over here. Our next theme is Headend remote management. So let me tell you about that. Well, virtually every device today is controlled to a network connection. It has been for like 20 years. You put the device in, you give it an IP address, and you control it from a laptop. That's not new. This has been the case everywhere. So you're already controlling it through a network. And it doesn't matter if you are next to the device on the other side of the planet. You can control that through a network. And it's not a Cobalt invention. This is nothing new. As I said, it's been the case for 20 years. The key point that we are making here in this presentation is that you couple that and design your infrastructure with enough flexibility so that you can switch in and out flexible processing resources as needed, and be able to monitor the signal at different stages so you know what's happening. So you have resources that you can switch in and out, and you have things that allow you to see what's going on everywhere in the path. And we're going to show you how to do that. And that is this next diagram. I didn't animate it because I want to show you everything at once. Okay? So on the left side here, you have your sources. Whatever it is, cameras, receivers, whatever, they are coming in over here. And if you need a test signal, it's better to have some test generators coming over here. On the other side, you have your transmission links, wherever the video needs to go. Transmission, studio, whatever it needs to go, it's over here. Okay? The next cool thing you have is you can connect a multi-viewer to this, and that multi-viewer to an encoder. So immediately you have remote monitoring of whatever it is that's coming in on whatever device you may want to have, and flexibly switched, so you can see things side by side. Now, the next thing you can have is have a bank of processing elements connected here. You see the output of the router goes to a bank of processing elements, and the input comes back. So what are those processing elements? Up, down, cross, frame rate conversion, audio processing, HDR, whatever. All these things that take video in, a frame sync, and do something to the video and come out. So the fact that they are connected this way, you can switch them in and out of the path. So this camera needs a frame rate conversion, just send it over here, bring it back, and then goes out where it needs to go. The other thing you can do for yourself is have some test equipment. Test equipment many times will provide a video signal, a screen or something. You can either hook it up to the router to send it where it needs to go, basically for you to see, or you can simply connect it to this multi-viewer. So there's something wrong with the signal. Closed caption is not working. Ancillary data is not what you need to do. You just route it over here and see what's going on. If you have the right test equipment properly connected in your infrastructure. So that's the dream. That's the architecture. If you build it like this, you have a very flexible network, and you can manage it like from anywhere. You just need to put the right size router in the middle, the right processing elements, and have provision for your test generators, your test equipment on the other side. So what Cobalt does about that? We have lots and lots of the pieces on that solution. We have the decoders, we have the encoders, we have the routers, we have the test generators and the monitoring elements, we have the multi-viewers, and we have a whole line of processing elements. And we will talk about those next. So the next one is the router, and then Chris was going to talk to you about that.
Okay, thanks, Zero. So this, what we're looking at is our latest routing open gear card that basically it's another device that fits inside of an open gear frame. The idea with this card is basically to have a very robust but small package that can exist alongside all the other resources or all the other elements that Cyril just mentioned in the frame that can be fully managed through dashboard, but also be able to talk to different other third-party control panels, like what we see here on this slide. Like one of them is the DNF. We can also talk to PESA as an example, or Lavo. So just being able to have that flexibility and being able to have a robust ability to basically manage my ins and outs. With this card, you have that basically covered. Now this has been a growing product, and it's taken us a little while to get to this point. But what we wanted to do is ensure that every signal that came in to the card from an SD through a 12G, that we recover in terms of making sure that the quality of the input and output was maintained, and that it was able to behave and perform all those different tasks that you would expect from a router. So as you can see here, we do the reference-based switching. We do a lot of third-party protocol support, and if you wanted to do define some controlling, we support the SNMP JSON and also the GPI control capability. This, as we see here, it comes in a 12x12 and also a 24x24. And depending on what you get, the backplane of this card will look a little different. But in general, the way you control it and customize through dashboard, it'll be basically the same process, just that you have less or more ins and outs. Again, this is the router card, and it supports anywhere from SD through 12G. Next slide. And now we have this other card that's it's essentially a DA distribution amplifier for 12G. This is sort of a unique product because we also have a built-in capability to support SFP input and output points. So depending on the SFP that we can have either fiber or even IP, and it's got a built-in cross point that sort of allows it to behave like the router card in a way. This, we offer it in 3 different models, one being a 1x16, the second one is a 2x16, then the third is a 4x16. Essentially what this allows you to do is have the ability to manage multiple, different combination of inputs and outputs, whether it's a baseband, fiber, or even at some point even discussing your IP 2110 or 2022. This has you covered. And it has basically all the bells and whistles that you would expect from a typical DA, but just takes it up to a next level with the ability to manage it properly through dashboard and also have a visual of what you're basically routing within the card. You can go to the next slide here. And this is a representation of what you would expect when you have your resources active, or you have a visual of what you're seeing within the DA card. So depending on what you have, including SFP modules, this will give you a visual of what's active or what's not. And then from there, those simple tabs allows you to basically define exactly what you want to change or switch over with the crosspoint capability. And then you can also tag your routing points and all that within the same space in dashboard. And then also I should also mention that the capability for the in terms of distance wise, we can do from let's say if you're doing SD signal management, we can do up to like 400 meters. But if you get to up to like 12G, we are basically doing about 60 meters, more or less. Obviously, you need to ensure that you have proper cabling and that you have a good signal to start with. You go to the next slide. And then this just brings it again, just illustrating again, how it changes dynamically as you're changing and as you're defining your resources within the DA card. You have this visual that allows you to see what's actually happening with your signals, and this also will allow you to, if you wanted to get somebody else to jump in and help you with this, it's not that difficult to learn to understand what's happening within the DA card. And again, this is dashboard. Anybody can download, and it's easily manageable. Next slide. Now we move into the this. This is what we call our new sort of a flagship next generation processing platform. This is our 9904 UDX. This has been sort of a kind of a continuation of Cobalt's, sort of legacy of being able to build cards that are multi-processing, that can support multi-formats. But in this case, for this particular card, we take it up to 4K, where we can process up to 12G or quad 3G. And what's unique about this card is that we have the ability to do different license options, so we can activate them on the fly, as Sir described earlier, and also in that diagram where he described, how do you do the remote management. With this, you don't need multiple cards. You have a card that is basically very powerful to do multiple service or processes at the same time, where you can, manage basically color, you can do audio, and then you can also manage all your, ancillary data if you need to within the path. And what we see here in the different blocks in this diagram, those are the different steps of processing. A lot of the black stuff that you see there in those little blocks, that comes as a standard feature by default. The little blue, labeling in some of those blocks, that's basically what we consider a license that you can, open up at any time with the license code. One of the key things that I should mention about this card is that this became our Technicolor sort of processing option for HDR, from SDR to HDR, HDR to SDR, but also has become the sort of default solution for even doing the 3D LUT processing. This has a lot of, basically built-in capability, but because of some of the features that require a lot of resources in the card, we are playing it safe, where we, don't activate or enable all the features at once. And we have to be very careful as far as, what you want to do with this and what type of workflow you want to have, because that would also determine what license options can be combined, or what, interfaces are going to be required. In this case, we also support, as an option, we can do Dolby encoding, decoding, and we can also do SFP for IP or fiber. So if we go to the next slides here. This is a representation of the different backplanes that we have. Initially, we had one backplane that was, our starting point, that covered the basic, baseband in and out of the card, including HDMI. But then through some customer feedback and being able to enable the card to do more, we offer now a solution that can be a slimmer version for a more dense application. And then we have three other options that sort of embrace the ability to have SFPs for ingress and output as well, and then also being able to manage audios at the same time. So that gives you the flexibility of being able to manage multiple licenses, not just some of the basic baseband licenses. And if we go to the next slide, sir. I think you may have jumped one.
No. That's it.
Okay, you took it out. So anyway, so I just wanted to, there was a slide that there's a list of license options that I wanted to mention. I mean, we have a whole list of licenses that are very similar to the other UDX and FrameSync cards that we have in the product line. But now, obviously, it's all depending on what you want to do. You would talk to anybody at Cobalt to give you some guidance in terms of what the workflow requirements are and what your expectations are, so that we can sort of guide you into what would be the best choice. In this slide, what we have here is our latest multi-viewer platform. This also has the same density, the same sort of scalability of the other products, but this is really a monitoring focused product that basically it gives you the ability to have a real 4K or a real true 10-bit monitoring capability with noise reduction, and it gives you the quality that you would expect in a monitoring system. This gives you all the typical controls that you would expect from a multi-viewer, such as being able to customize your layouts, being able to set up your labels, color for the windows, sizing, and then also being able to support the closed captioning, tally, UMD, and all that. But what's also unique about this is that we have, depending on the model that you get, in this particular diagram, we're illustrating an 18 input card that has basically all the inputs are fixed as a SDI baseband input. But we also have one that's a 6 input that allows you to have a 4 HDMI input module that gives you that capability to bring in HDMI native sources and combine them with your SDI sources to give you a nice clean monitoring in 4K. This has been now our latest solution for monitoring. If you need to cascade, this is not really the product for that. This is we're trying to keep that as a highly dense package in a card. But again, it gives you that flexibility to have a true 4K monitoring capability. And again, we also have some advanced features like quality control, but that's on the smaller 6 input multi-viewer. Next slide. And then we also have this, as Sarah was pointing out in his diagram, some products that oftentimes people sort of ignore or overlook are these products that we've been actually providing as a solution for a lot of our customers. And one of them being the 9978 Engmon. This is a product that shares a lot of similarities to our legacy multi-viewer, with the exception that this has a lot of basically monitoring tools built into the card that allows you to basically do a lot of ancillary data monitoring, audio level, quality check. You can also, if you're doing SCSI messaging, you can also get that as a log. You can see the timestamp. What I see oftentimes is that when I look at operators, most operators oftentimes on their desk, they have like a scope for monitoring this very simple or data-driven logs. And what I recommend is that instead of having a scope, this will be a better solution that actually gives you a true, if you're monitoring 3G or HD or SD, this will give you that true picture monitoring capability. Plus, on top of that, you have the added value that you can also monitor all your channels, your captions, ancillary data, and all that within this card. And if you are going to be setting up a system to monitor all that data, I would recommend that this will be one of those products to consider, because it's a multi-channel. It's not just the one channel. You can set it up as up to 5 channels to monitoring, and again, it's all controlled through a dashboard. And then the other product that's also in our catalog is our test generator, the 9960, as you see here. This has the ability to have 2 independent ways to generate a bi-level, tri-level, and a test generator. And you can also generate a tone if you need to generate that. Also be able to do some SCSI and caption processing if you wanted to. But ideally, this is a product that oftentimes sits within the frame to service other workflows, as I mentioned, by providing that reference through a bi-level, tri-level source, or even having a quick pattern just to make sure that you have a valid output, right? So this, again, it's a card that has two independent channels that behaves independently one from the other, and it can serve in different purposes within your whole production chain. Next slide.
So,
and then we have some up and coming products we'd like to mention. One of those products is the this new, what we call the standalone BVG 1300 FR. This product basically has been a product that's been a popular demand by a lot of our customers, especially since we have been providing solutions as a standalone with our BVG 1000 product line. That also sort of kind of falls in the same as the the BVG blue box, the small little throwdown boxes. This basically is not just a simple little box that doesn't do anything, that just holds the card and powers up. This has a lot of advanced features, and as you can see from the slide, we have redundant power on board. We support SNMP, a lot of the advanced onboarding networking capabilities to basically define a workflow such as what Ciro defined earlier, and then it has a lot of the more advanced features that you would expect from a regular open gear frame. In many ways, this is a frame that could easily rival even our blue HPF frame, or even the OGX frame in some ways, because it has all that capability. The only limitation is that it's a one RU box that has just the ability to host one card or two cards, depending if you have a split rear or backplane. What's unique about this is that you can talk to this frame directly from dashboard, or you can also control it directly from the front panel. Another thing that we are possibly looking at is the ability to access this through a different path via the web, but that's been a discussion. But it's something that just being able to give the user more capability just opens up that much more the flexibility to do more real-time monitoring and working with multiple remote locations. And again, if you have an open gear card, it's a basically simple process to install one of those cards in this frame. This frame will also accept any card from any other third-party open gear manufacturer, as long as the backplane it's compliant within the open gear platform. This should be able to host it properly. And then, like I mentioned earlier, if you're using one of our cards that happens to have one of the split rear modules, you can properly host two cards and be able to have multiple channels in a small little package. Next slide. And this is basically a continuation of the 9904 UDX card that I started mentioning earlier. But now with this, something that was new and that was going to be released at NAB was the ability to have our UDX card to be a multipath processing system. So basically, the idea is similar to what Ciro mentioned with the the encoder. With this card, you basically you can purchase this as a one-channel card, and we do have a lot of customers that are using this product as a one-channel system. But you can certainly at some point now we have the ability to activate at any time different channels of processing, so that within one card now you can increase the density by having it function as a multi-card almost, but it's a multi-path card that basically can do independent color correction. You can do frame sync, up down cross conversion, and then also the ability to process your audios. As you can see from this slide, we can do AES, or we can also do MADI, which is coming down the road. One of the unique things again is that if you have this card and you have it in a small let's say the BVG 1300 with the small profile backplane, now you have a nice capability built into a small package. But obviously, the audios basically will be sort of compromised, because a lot of those IOs that you see on the backplane are associated with the audio part. But if you're doing everything embedded and you're okay with that, then this will give you that flexibility and the robustness to do all your frame syncing, up down cross converting, and also color correction. And then another thing that I find very interesting about this, being able to be multi-path, is the ability to use the 3D LUT license to be able to apply different LUTs. If let's just say I'm on set or I have a very remote, sort of flight pack configuration, I can bring this without having to bring a whole, rack to do, what's required for that production, right? And this, again, I think it's going to be expanding. And if we were to, discuss with our design team, they'll tell you that, this has a lot of capability, but just you want to be careful as to what we enable and activate on the card, just so that we don't compromise the signal quality and the density that we offer now. So again, this is one of our key highlights that we were going to showcase at NAB, and I think it's worth just keeping this in mind, because this product will give a lot of reasons to have a nice package with being able to process all that that you normally do with multiple cards in one card. And again, it's our latest 9904 UDX. Next slide.
Okay, thank you, Chris. The next upcoming product we would like to talk about is the Cobalt's putting together a network management system. It's based on EMS framework that's been around for a while. It's web-based, so and it's something that it's going to look at a network of products and manage those. And the first application from that is going to be N+1 encoder redundancy. We're also going to do stream prioritization and bandwidth graph. So this is the focus. The initial focus of this product would be to manage video over IP links, but it can be extended to work with any device with SNMP support, including the third-party devices. So this is an upcoming product that we wanted to tell you about, and let me show you a few screenshots. This is how it's looking like. This is running inside the browser. You see here that's a network with 4 devices, which are all 4 encoders. There's some that are in alarm, and you see some details about the alarms. I know it's a lot here, and you're not going to really see the details. This is just to give you a flavor of what the NMS is going to be doing. Here's another example, an inventory screen, and you see no alarms at this point. These are the encoders that this particular NMS is managing. Here's this historical alarm example. So this is what happens in the past, what kind of alarms were, and they got cleared or not. So this is the kind of stuff you can expect from the Cobalt NMS system. We want to talk about a few more products. So Chris is gonna take this one.
Okay, yeah. Let me briefly just this is serving to sort of recap what Cobalt offers as a solution with all the different tools and platforms that we offer. So basically, up to now, we've been talking about a lot of the products that are within Cobalt's catalog sort of reside within what we call the Open Gear platform. But we also have the BBG 1000. That basically what it does, it's a similar form factor as what you saw with the BBG 1300. It's a standalone 1RU enclosure that becomes the BBG 1000. This allows us to be able to package an Open Gear card and put it into this, a BBG 1000, sort of form factor, to give users that flexibility to have a portable system that also continues, providing that essential processing that you get within an Open Gear card. And what's nice about this is that you can fully control it through the front panel, but you can also fully control it, or you can continue to control it through the dashboard, right? So that's what that is. That's what the BBG 1000. Now, what's different about this BBG 1000 platform versus the BBG 1300 that we have now is that this is basically fixed. So the backplane is fixed, and the setup of the enclosure is fixed. So the users cannot swap out any cards or cannot do any modifications to it. If you do desire that, it has to be sent back to the factory, and it has to be sort of addressed and you know, maybe updated. But in that case, you know, what we did is we identified some of the key you know, functionality that was desired within the open gear cards, but in a portable system, and that's what we define as a BBG 1000. And later on, I'll mention a couple of, you know, some models that we have that fit within that category. And then obviously the blue box group, we basically have been designing and selling these little throwdown boxes for many years now, and they continue to be like the staple of you know, the product line, because although they're very simple, they offer like a lot of bang for the money, and the quality is the same as the cards, because basically what that is we're sharing a lot of, you know, we just bring down the design from a card into this and package it into a small little throwdown that makes it basically what it is. It's a small little throwdown box that has the flexibility to do some basic, you know, like converting interfaces or signal, or even you know, doing like a embedding or de-embedding audio in fiber. Then the two other blades that you see on the right side there, the two elements on the spot check, these are basically servers that we use for, you know, managing audio. So if, let's say, the elements, this is a device that would take my transport stream packets, and it'll basically open up the packet and normalize the audio, and then keep streaming or passing the signal along. That's what that does. It has the ability to do multi-programs. You can do you know, stereo or Dolby, and it's a nice system in case, you know, that's a desire. And then the spot check, basically this is our basically compliance. It'll basically keep things in check just to make sure that we are within compliant within the COM Act. And it'll basically do a low res recording, and you know, if at some point somebody comes back and says, hey, I need to check you know, to see if you are within compliance, you have a way to prove that. And again, this is it's a server that provides that service. Next slide. And then what this is illustrating here is the different categories that we offer, you know, for the Open Gear platform. This is basically, as you can see, there's different categories. So we have, you know, different categories for audio, color correction, fiber optics, multi-view routing, compression, branding, frame sync, and so on, and up to 4K. All this has different, you know, products that are associated with those categories. But one trend that we've been actually now sort of moving towards is the ability to offer multiple categories into one card, which is what Cyril was talking about. You know, being able to offer, you know, sort of like a service, a software as a service within some of the cards. As an example of that is basically the UDX, the 9904 UDX, that basically combines multiple of those categories into one card. But again, we still continue to make very specific and dedicated products. So if you want to just do frame sync, we have a dedicated frame sync product for that. Or if you wanted to just do a clean distribution with nothing else, then we have that. If you want to do just a fiber, you know, link, then we have a product for that. So within all these different categories, if you go on the website, you'll see that there's all these categories listed, and then there's different models that sort of go along with that, and then you'll see exactly different options. And then within those options, you will also be able to see what backplanes and what other you know, licensable options may apply to some of those products. So again, this is the Open Gear platform, and then we have the HBF and the OGX frames that are the most current Open Gear frames in the market. You can get either one from us, but the only exception here is that the blue one, our you know, frame, it can only be acquired through Cobalt. Next slide. And then I'll mention a little more about the BBG you know, blue boxes, and then just before, you know, just want to make sure that I mentioned that these are 5-year warranty, and these are made in the US. And then I'll go to the next slide, and I'll describe different categories again. So similar to the OpenGear platform, we have different categories for, if you want to do a fiber TX in a single channel or dual channel, and then we can also do a bidirectional, if that's what's desired. We also have an HDMI to fiber, fiber to HDMI, and then we have one that's, as an example, that's an SFP capable blue box that allows you to have a transceiver. It can be a TX, RX that converts to SDI or HDMI. And then we have these two products that have been sort of interesting products in the past couple years, the encapsulators for 2022 or 2110. These are a nice little, inexpensive solution for somebody that wants to start, testing or using IP in their infrastructure. This is a nice way to get there. And then we have embedder, de-embedders, and then your basic SDI to HDMI, HDMI to SDI, analog to digital, and then finally we have our 12G DA that also shares a lot of the capabilities and quality as the 9915 DA card. Next slide. And then this is an illustration of what you expect to get if you get one of those BBG blue box drill downs. A lot of our customers, I think, from the feedback that I've gotten, is that they don't think they have access to being able to remotely or through a web GUI monitor their BBG little boxes. And I just wanted to mention that depending on the product that you have, once you plug it into the BBG box, you'll be able to see different controls or monitoring capability. So this just illustrates that. This BBG config USB GUI, you can download it from our website. And again, depending on what product you have or you're interested in, then this is going to be an example of what you would expect to get. Next slide.
Okay, that was the presentation. Thank you very much. Now we open for questions if you have them. Don't be shy. Okay, so we are going to post a recording of this presentation on YouTube.
Unmuted.
If you want to have a copy of the slides, just contact our salespeople and I can provide you a PDF of this presentation. Thank you very much for joining. And again, last chance for questions if you have them. All right. Thank you for your time.